Hey there, Luke here. So this is the machine that I call Mongo. So what it is a Rigidbot XL. It is a build volume of 16 inches across by 12 inches deep by 14 inches high in its standard build configuration. I don't use a standard build configuration. That configuration involves a different extruder there, as well as a standard Mark 10 hot end, whatever that is, similar to what Flask Forges and the Megabot X2 is like. But recently I had an issue. So first off, this is a bed slinger. It's similar to a Prusa i3, where the X and Z are on the same carriage. So the Z axis raises the X carriage here, and that moves up, and then the Y axis, the bed, moves back and forth. So what happened was, I, like a complete idiot, had the wires on the Z axis here, on the inside, so to the inside. That, unfortunately, collided with the heated bed cables and caused a fatigue failure from going back and forth, and caused this Z motor not to work anymore. So this means I needed to buy a new Z motor, okay? But as maybe you can see, disassembling this thing is a bit of a task. And while this would solve the issue, it's still going to be pretty annoying to do. And I came to the realization that even though I'll be fixing it up, and I've been working on these braces here, that it would never be as fast as a small machine like my regular Rigidbot over here behind me would be. So, I've always wanted to design my own CoreXY. So what the difference is with the CoreXY compared to this i3 style. So as we talked about beforehand, the i3 style has a raising Z axis, which also carries the X axis, which carries the hot end. And then there's a separate Y axis, which carries the bed, and the bed moves back and forth as you hear the wonderful squeaks of it. What a CoreXY is not only does it typically use a gantry that stays on the same Z axis and the bed just moves up and down, but it also keeps both of the motors off of the drivetrain or the moving components. So right now, the Z axis is both here, move up and down, and they move the X axis right here. So what that means is there's more mass to move around. It was the same thing on the MakerBot, the X2s, where even though it was a stable gantry and the bed moved up and down, one of the motors, I forget which, one of the motors still would move in the X or Y direction when they moved. But the CoreXY will allow me to put a motor here and a motor here and a belt system that goes around. I'll probably have a picture of what it should look like. And then that will allow me to have a super light moving mass in the form of just the extruder. So I can choose to go Bowden, or I could choose to have a direct drive, take a little bit more mass, but yet have much reduced mass. So what that means is I'm going to have to completely redesign this all from scratch. I kind of have a preliminary design taken care of already, but I need to go finish prototyping it. My current plans are to reuse the Z-axis, both this and then the threaded rod, to reuse the Y-axis for the linear rails and just rotate it this way so it has more stiffness in the vertical direction like it should. I'm honestly not sure why. I know why. It's probably much better for mounting things easily, and it makes a predictable surface and easier to work on from above because you can just do the screws from up above. But from a stiffness standpoint, it's far better to have them vertical so that both the forces down are fighting against each other. It's similar to an I-beam. When you want to support stuff across the span, the I-beam should always be vertical with the I in normal mode. So it's the same type of problem, because when you have twisting on there, it goes against both bars instead of not. But so I plan on reusing the X, the Z, and then the Y bars as well. So the Ys will go along both ends here, and then the X's just be rotated like I said, and then go across the top and bottom. So that's pretty much the plan here. I will have stiffeners along all of these sides, both here and across. I may make these a little bit wider to make them more of a triangle. Another thing that having CoreXY allowed me to do is will allow me to fully enclose this bot, because the way that this one is designed is that the bed goes well outside of the boundaries of the frame, so you need to build a really stupid sized box. And so having CoreXY with the bed only raising and lowering means that I can enclose all this region without any penalty. I could actually box it on the inside of here and not even on the outside. So that's, you know, some more good news. Pretty much the most difficult part about it will be trying to figure out what the best way is to attach the bed. So this bed sits on a carrier plate on the bottom where it bolts into 4 screws. I'll probably eliminate a lot of the springs and go for more of a stable mount so I don't have to worry about it, and kind of let automatic leveling take care of the rest. Because if we don't have to worry about screws in the bed, that's just one additional part where it can be stiffer, even though the bed won't be moving. That's the biggest reason I want to switch to CoreXY in this machine, is just to keep this bed from moving. It's a giant bed, and the more stuff you put on there, so that's the 15-pound spool that I have, and the more filament that you extrude, the heavier this gets and the worse the print performance gets. It's really frustrating. So by moving only the head, which stays the same mass the whole time, stays in the same position in space, it doesn't go up, and only moving this down, so gravity assists it when it does have to move, when there's prints on it, it's a big difference. Alright, so here goes. I'm going to take it apart. I am going to be praying that this Rigidbot back here doesn't fail while this one's apart, because I need this one to continue printing parts. So I have a decent start on the design for at least one side of it that I plan on mirroring and changing only the things that have to change for that other unique side. But I'm going to take it off and start taking out the rails to see if the parts actually do fit the way that I think they are, and to see what changes I have to make. This will also be a great time to improve my excellent cable management. So I'll be moving the whole control board up into the main gantry area there, and just try to make sure the wires flow where they need to flow and look actually professional and put away, instead of this half prototyping, half laziness mess, which caused the initial break in the first place. This is why I have problems. So I hope you're able to see it, but there is a small crack right by my thumb that actually runs through the whole thing. Hopefully I'll zoom in and show you this, but that's also what happened when it broke. One motor was correctly turning, the other was not, so it actually cracked this fitting here. I do have several extras available, but to do this I would need to do all this work anyways, so if I'm going to tear it apart, I might as well do it. But there is the top of it taken off. I am going to take apart this unit here and then see if I can start with the the base assembling of it. Actually, never mind, I also have to take off the bottom pieces there as well, and use the Y-axis to run along the top. But that I can do at my bench, and so I'll get everything moved over and clear off my workbench, because it's just full of junk anyways. So I have the top off now, and I was just taking a look at my initial prints. So what I initially did was I printed the corner, and I printed my first attempt at a Y-axis carrier. So across here will be the X-axis in the longest section. That'll also use the tools. So I was just checking the clearances that I had from the top of this here to the Z-axis post here. So there will be a post that come up down the middle, as well as just to see how well it moved and if it made sense where the belts were. So I guess the first round of me actually printing out full versions is that I guess I read the wrong size specs for these LM8UU bearings here. Apparently they're slightly bigger than I thought, which is throwing off all my measurements, because I wanted them to be somewhat of a press fit into the back here. I will have a back piece that will fully enclose them and compress them, but it appears that while I got the length right, the diameter is not working out at all. So I mean, they do snap into place and they stay there pretty well, but that's not what I'm looking for. I'm looking for more submerged, where the center line would actually line up with that half moon that I put in the surface there. So another thing is where this belt lines up. So I'm gonna have to move this out slightly. The more square I can get it, the better. The motor is actually the limiting factor as far in as these belts can go. So that's the that's kind of the hard part here, is that if I can't move the motor any more in on this end, just due to other space constraints like running into the actual tube here. The good news is that by utilizing for the y-axis at least, by utilizing their design for how they retain the linear rail, I can get a pretty stiff and reliable assembly where I don't have to worry about it there, and it's fairly easy to take apart and service, because it's only the 2 screws there and it pops right out. So that'll be a guaranteed surface for this time. For the y-axis, or the x-axis going across, I tried to copy what Prusa did with theirs, where they have ever so slightly undersized hole here, and then a gap at the top here. That so when you press it in, it expands and that holds it in by friction. So it'll require me to force it on there when I run across the x-axis, but it should work pretty well. But for right now, I have to go back and change these sizes, move this belt system over a little bit, and then print out some new parts. Now that I have these two things settled out, I'll probably print a motor side and then get a full left-hand side going, and then start to work on my across. So that's the good news. All right, so we do have both sides of the Y gantry printed. As I feared a little bit though, it appears it is a little too long. So if you have it on one side here and hooked into the 2 LM8UUs on that side, this side is too long, just a skosh. So I took a measurement in the model here, and I will be going and cutting those off, cutting these 2 rods down just a little bit so that it fits in here. Some other improvements that I did make was, between a couple of different revisions, was I added stiffening here and here as well, and made sure that those still fit in. But so now the entire stiffness of this beam is actually just from the stiffness of the bars themselves. When I flex it, there isn't that much plastic deformation, which is pretty much what I was shooting for when I designed the block. I want as little deflection as possible, so when I add the x-axis carriage here, it will work well. Speaking of the x-axis carriage, here's what I have. So focus, there we go. So what I have here is E3D V6. That's what I love to use. I love the crap out of them. Check out my other videos, but it's all built around that, and then a direct drive form of the new extruder. So this gap here was because I missed a critical thing of having to assemble the top end there. So there is a PTFE tube that will need to run into here to fully make a really tight joint. And with the direct drive version, I don't think I'll be able to pry that out during the video there, but it didn't fit I wasn't able to rotate it in place here, so I had to actually drill it out. And revision 2 of this, or revision 1.1, because it's not a base change. Anyways, the update to this will include a nice rotated spot, but I drilled it out just to make sure everything else fits. So I'll have to loosen up this piece that slides in and locks it in place a little bit around the edges, since it was pretty tight. I mean, I didn't design it with any looseness built in already. So the fact that it fits, but fits barely, is exactly, this is why it's so fun. And another couple key things here that I have is just this beautiful filament path. So hopefully I don't shadow too much by lifting it up. But as you can see, there'll be a LM or a 608 ZZ bearing that rolls along here that will just make it absolutely gorgeous, and no place for the filament to go. So this should be as good as all my other new shooters that, you know, has perfect filament performance here, while still maintaining the same size of package. And in addition, the fan will just be basically quick mounted, so you just slide it in, throw in a small screw here, and away you go. It'll have a decent flow path there, plenty of space for the large 40-28 fans that I use here. So that's at least the first model. And then there are 2 things up here for cable management, and on the X carriage there will be another feature that will be used for the cable management, because as we all know, I need to improve at that, so here I am. I've also built in at least one feature here just in case I need to use it for mounting the inductive sensor that will come, because since I'd like to switch this over to far less spring oriented and much more just kinematic, so basically just have a couple tilt and no springs, no tightening, tensioning, all that kind of junk on the bottom. It's nice to have that inductive sensor so that we can have live leveling the entire time and get those beautiful smooth first layers. So far, you know, everything's been fitting. It looks like it actually is designed. So I'm gonna go take out this to the yard, or not to the yard, to the shop outside, and get her ground off. So here I have it set up. It's in the vise. I use electrical tape or some sort of sacrificial material so I can clamp down on it and have a secure hold, but yet not scratch up the surface here, because the vise will probably scratch it. You can use whatever the heck you want for cutting it, but I just use a simple angle grinder here to take off a portion that I measured. It's pretty small, as you saw before. Just always remember your safety glasses. I can't not remind that, because I don't want to lose my eyes. So. So thankfully the precision and roundness of these edges, you know, doesn't count. I cooked them real good, but I cleaned them up, so now they'll be able to slide together and put back in. So let's see if I made the measurements right. So it looks pretty good. I got the X moving right. So one thing to note here, there aren't caps on either side, which would actually lock it in quite a bit more, because currently I'm able to do this. But that is only because the ends are able to flex, and it's able to kind of rock around these LM8UU bearings. But once we have the backers actually installed and tightened down and have the LM8UUs fully encapsulated, it should be good to go. So I think that this should be pretty stable. Uses 2 LM8UUs per side here, and then the X gantry Uses 2 8 UUs that are fully stacked, so there's not even a divider here, and then one in the bottom, which apparently I completely oversized. But it'll use the same kind of thing. It'll capture it in the front and then have a backer place that goes through, and it will have a hexagonal key there for the backside to always plug into, so that way we can be sure that there's force going through, as well as 2 holes there. So I think that'll conclude this version. Next we will go through setting it up and getting all the electronics and the motion system actually working. So if you like this, feel free to subscribe, like, ask questions below. More than happy to have, answer questions. If you think that I did something wrong, let me know in the comments. I want to learn. That's kind of why I do this. So it's partially because I want a better machine, and I'm also doing this because I want to be able to design a complicated. I mean, this is pretty simple stuff, but a system with many parts. So any sort of feedback, positive or negative, as long as you're not just telling me I'm an idiot, that's not helpful. Feel free to leave below, and I hope you appreciate it. I'm gonna go get some smoking pork out of my smoker and start going. Hasta la vista.